Hello, this is Hara from OS Team, and I'll be showing the demo of the video. So after successfully flashing the code to the board, this is the main menu that has 3 options, but we're interested about the light
brightness
UI.
50%.
So when we press it, its default is 50% brightness, and it announces it.
Brightness is at 75%.
And as we go up, it increases the brightness and announces it as well.
Brightness is at 100%. Brightness is at 75%. Brightness is at 50%. Brightness is at 25%. Brightness is at 0%.
So it shows brightness for, it changes and announces brightness for 0%, 25%, 50%, 75%, and 100% successfully.
Hello, I'm Mohammed Ismail, and I'll be showing off our diagram for our project. Let me explain how the system works. At the very top, we have the input layer, the user input layer, which includes the knob and buttons. The knob lets you adjust the brightness, and the buttons are used for tasks like switching between warm and cool lighting or going back to main menu. The inputs from the user go to the event handling layer, which processes them. For example, if you turn the knob, this layer checks if it's increasing or decreasing the brightness, and then sends that information to the next layer, which is the control layer. In the control layer, there are 2 main tasks. The first task adjusts the brightness level and updates the display to show the current percentage, like 50% or 75%. And the second task announces the brightness level using audio. These tasks run separately to make sure that the system stays responsive and smooth. Moving on to concurrency control layer, it manages how tasks share resources. For example, when the brightness level is being updated or read, this layer makes sure that only one task accesses it at a time. It prevents conflicts and keeps everything working properly. At the very end, we have the display and audio output layer. This layer updates the screen to show the brightness level and plays an audio clip to announce it. For instance, if you set the brightness to 75%, the screen will show you 75%, and you'll also hear it saying 75%. All these layers work together to handle inputs from the user, processes them, and give you clear feedback through the display and audio. Thank you.
So unfortunately, I wasn't able to get the bonus feature fully implemented by the end of the project, but I thought it was important to still go over the documentation and the approach that we took here. So the idea is similar to before. We create an RTOS event group, define that up here. We define 2 tasks for this group, one of them being our temperature control, one of them being our brightness control. And then down here you can see the definition for brightness control. What this will do is infinitely run, waiting for the bit, and it will check to see if the dial is being turned, and it'll check the current light brightness. And if it's less than 100, it'll increment it, and if it's greater than 0, it will decrement it if you're going backwards. And then lastly, it will send the LV arc set value, which updates the UI. It'll update that with the temperature, the temp arc, and the current brightness, rather than using current. And then I believe this is the same thing here. This is for the UI portion. And then down here we have our temperature control task, which runs true, waiting for the bits, and it checks the current temperature and defines what the brightness should be at based on that current temperature. And then at the end, it's asynchronously sending that it's sending the bit to this event group so that it knows to run the brightness task in the background and await that the right dial or the left dial. And then at the end, I can get rid of this here. At the end, it's triggering to start the temperature event, so that's I guess the entry point for this function. So unfortunately, this wasn't able to compile. This was incorrect, but I think this is the correct approach, and I think it was worth a shot trying. Thank you.